Click the bell icon to get latest videos from Ekeeda.
Hi guys, today in this video lecture we will learn the FET types, concept and symbols. So what is FET? FET is nothing but Field Effect Transistor. Whatever transistor we have studied till now is nothing but BJT, that is bipolar junction transistor. Then why the need of FET? That only we are discussing this FET concept, types and symbol here. Hey, hi guys, today in this video lecture we will learn Field Effect Transistor, FET, types, concepts and symbols. As far as FET is concerned, we have learned the bipolar junction transistor. So in bipolar junction transistor, we have not yet discussed about field effect. So field effect transistor is another type of transistor. It will give you the amplification, it will give you the application as a switch as well, but there are more advantages over BJT, and that's why we are learning FET. So let's come to the point of full form of FET. It's nothing but field effect transistor. Then how it is different than that of BJT, that we'll have to understand first. We will take one points. First of all, your BJT was current controlled device. And your FET is voltage controlled device. Now one question obviously will come in your mind, that what is voltage controlled device and what is current controlled device? As we have discussed in BJT, IB is a major factor that is controlling the whole action of whether it is amplifier, whether it is of switch, whether it is of buffer. That whole control action will be controlled by the current IB at base current, right? But here in this FET, though it is of 3-terminal transistor, it is controlled by field and ultimately it is controlled by voltage. This is because we all know that E is equal to V divided by D, whereas E is nothing but electric field, V is nothing but potential difference, I can say, and D is nothing but the distance between 2 points from where we will be getting the potential difference V. So ultimately, what do we get? Electric field increases if your distance between 2 points decreases, but voltage is kept constant. If we vary the voltage and keep distance constant, then also your field will get affected, and if field get affected, your operation will get affected, and that is why we are going for your FET as voltage controlled device. This is the first point. On that basis, we will differentiate BJT and FET. Next point is BJT is bipolar and FET is unipolar. Again one question, what is bipolar? What is unipolar? See, what is mean by polar? It is having one polarity, it is positive or negative. Bi means two. So complete operation of BJT is controlled by two parameters. One is minority charge carrier and another is majority charge carrier. If you look at the operation and characteristics of BJT in the previous video again, you will get to know that your BJT is bipolar device. This is because we are controlling your operation of BJT because of two majority and minority charge carrier. Obviously, if in a semiconductor majority charge carrier is of positive, then minority has to be negative. So both the parameters are equally important for the operation of BJT. But is this important for FET? No. So that's why this FET is of unipolar device. So only either positive charge carriers are important for the operation of FET, or negative charge carrier are important for the operation of FET, rather responsible for the operation of FET, right? So that's why the Namakaran of BJT is bipolar and FET is unipolar. Here in the FET, we are not stressing on bipolar or unipolar. This is because we are stressing on one particular parameter, that is field effect. So this is how the two different parameters we have got. On the basis of that, we have discussed the differentiation. Third important aspect of BJT and FET difference is and in FET input impedance is high. So for BJT your input impedance is less and FET input impedance is high. See, recollect what I told in the previous videos. For amplification we have the characteristics as your input impedance must be very high, your output impedance must be very less, and your voltage gain, current gain, power gain should be moderate high. So if I compare BJT and FET, then FET is more preferred for amplification than that of your BJT. One more reason behind this high input impedance is it's in the form of mega ohm, and the reason is because your gate current is 0. We don't have any gate current. What is gate? That we'll learn later. That is one of the terminal of FET. So this is because we are having the high input impedance, because Ig is at the input side. If current is 0, then resistance ideally it should be infinite. After all these difference, we'll come to last difference. Rather, we have more and more differences. If we dig out small differences, then we'll get many differences. But important aspects as far as BJT and FET concepts are concerned, this is nothing but thermal stability. BJT is less stable and FET is more stable. And the reason behind that is BJT is a bipolar device, and that is why we do have minority charge carrier. Current is much responsible for your operation as an amplifier. But for FET it's a unipolar device, so that much responsibility of minority carrier is not there. So in FET it is more stable, and I can say that the thermal runaway concept is not there. So that's why it is more immune to temperature. We all have studied that thermal runaway. If ICO increases, minority charge carrier current increases, your IC increases. Your IC increases, then participation increases, heat increases, and again temperature increases. This cycle goes on and BJT can get damaged. But this will not get in the picture of FET, right? So this is how we have got the difference between FET and BJT. Actually, the BJT is the accidental invention. We want to find out the device which is dependent on the field effect. We want the transistor which is on the basis of field effect, which is voltage controlled device. But accidentally, we have got in 1957 the invention of BJT. Again, that's a different story of research. We will learn the FET now. We will dig out the FET concept. We have to find out the types of FET and the symbols associated with it. Here we will do the classification of FET first. This FET, nowadays we do have lot many invention in the form of double gate, MOSFET, then FinFET, but for your syllabus we have to study whatever is been completed in the form of research, that is nothing but junction field effect transistor, MOSFET only. That much is in your syllabus. So what we will do, we will classify in a whole. First of all, first is junction field effect transistor, that is JFET. Second is MOSFET, right? Then third one is MOSFET, and so on. We will be getting the types of FET in the form of FinFET, multiple gates, double gates, right? So these FETs we will not cover for this particular video. We will start with JFET. This JFET further classified in the form of N-channel JFET or P-channel JFET, right? This is on the basis of semiconductor that we have used. So if we are using N type of semiconductor as a channel, then we will say that N-channel JFET. If we are using P type of semiconductor, then we can say it's a P-channel JFET, right? In the MOSFET, we have two more further classification, that is nothing but DMOSFET, that is called as depletion type of MOSFET, and another is EMOSFET, that is enhancement type of MOSFET. Here channel is already present, and here we have to form, we have to induce the channel. Again, D and E is further divided into two parts based on again the semiconductor as a channel. So if this is N channel DMOS, this is P channel DMOS. Here we will be getting the again N channel and here P channel. So this is all about the description of classification of FET. We'll go to the next slide and we will find out what will be its symbol and why this symbolic representation is particularly for particular type of FET. First we will go for junction field effect transistor. For N channel, we have symbol this arrow indicates the direction of current. We have three terminals for JFET, namely drain, this is gate, and this is source. When we will learn the symbolic representation of N channel and P channel, we will also learn the water analogy for JFET. So this is for N channel. Current will flow from drain to source, and here the controlling parameter, which is nothing but gate to source voltage. So we will note that this is plus and this is minus. This voltage is nothing but VGS. This is nothing but a controlling parameter. It is very important. Here we do have the arrow is in another direction. So obviously if we change the type of carrier from negative to positive, your direction of current will be different. So we can say that here it is drain, here it is source, and here it is gate, right? Here as well we'll be getting plus minus VGS. Okay, now Coming to the part of N channel and P channel, we will say that current is in the form of responsible parameter electron. So electrons are responsible charge carriers. And here we'll be getting holes are responsible charge carrier. So this is all about junction field effect transistor. Coming to next, that is MOSFET. It's called as metal oxide semiconductor. Baki all you know, FET, right? So I will write it as it is. Metal oxide semiconductor FET. And that have different symbols because MOSFET is used more probably in your switching purpose, in your digital circuits, high speed. We are having different types of symbols for MOSFET. So we'll start from N channel. Hey guys, this MOSFET, initially we will start with enhancement type of MOSFET. I forgot that the MOSFET is again classified into D MOSFET and E MOSFET. So we'll have to first note this down as this is for E MOSFET. Okay, when we will go for E MOSFET, this is the symbolic representation for E MOSFET. This gap is represented with capacitors in between gate and the channel. So channel is not yet formed, right? We have to induce the channel in E MOSFET. This arrow again represents the direction of current. This is how the representation of N channel E MOSFET. For P channel E MOSFET, just change the direction, that's it. And again, capacitor is represented by these two parallel plates in between channel and gate. This is drain, this is source, this is gate, same Ram Kahani. Again, we will go for the next symbolic representation of EMOS only. In some analog circuit, we use this representation. This is called as substrate terminal. This is a fourth terminal in MOSFET we are introducing. So MOSFET is not a 3-terminal device, it's a 4-terminal device. This is D, this is S, and this is substrate, or also it is called as body. This is G. And here we are changing the direction. So in this direction, we are having movement of minority charge carrier to have the layer of N channel. Similarly, for P channel, we will just change the direction. Right? So this is how the representation of E MOSFET, right? In digital circuits, we can also represent this E MOSFET for N channel and P channel in a very simple manner as like this and like this. This bubble represents that it's nothing but P type. And if bubble is not there, then obviously it will be N type, right? So this is only for the digital circuits we are implementing this particular symbol. So this is how we have learned the E MOSFET. Then for D MOSFET, the symbolic representation is something different. Let's learn for only N channel, P p channel ka, exactly simple. You can do that of your own as well. This is the representation for n channel. Direction represents the direction of current, and this filled gap is saying that channel is already present. So a channel is already present, we just have to maintain the flow of current, that's it. And that is why this is the filled two parallel plates. If we compare the previous symbol of E MOSFET and now D MOSFET, here in E MOSFET we just have two vertical line, and now in D MOSFET we have filled that particular area in between two lines. That only the difference between E MOSFET and D MOSFET. And then in D MOSFET, so this is how we have learned the D MOSFET and E MOSFET as well. You can also form the P channel ka symbolic representation for D MOSFET. Very simple, just change the direction of arrow, then we get the P channel ka D MOSFET symbol. So this is how we have learned a lot for the concept, types and the classification of FET. So stay tuned for further videos. In that we have to learn the characteristics, working and the construction of FET, how exactly current is flowing, how do we get the amplification in your FET more preferably than that of BJT. So this is enough for this particular video to learn FET types, symbols and concepts. In next upcoming videos, we will learn the characteristics, working and the construction of JFET, how current is flowing, how the operation as an amplifier for FET is more preferable than that of BJT with all other parameters, AC and DC analysis as well. So for that you have to stay tuned for upcoming videos and you have to subscribe the Ekeeda channel. Thank you so much.